Alright, this is the first of two videos for today's lesson. Today we're going to do a few word problems, okay? We've done a lot of areas of parallelograms and trapezoids, kites, circles, that kind of stuff. Now we're going to put it to use. Really the idea here is that we just want to draw some good pictures given some word information, right? We want to be able to read a problem and figure out what the question's asking, draw a good picture, use that to solve some problems. So, this is two videos. I'm going to split it up into, because I think maybe one would be a little bit long. I've got about 5 word problems I'm going to work through. Here we go. Problem number 1. Grandma has an old family recipe for blueberry pancakes, and she can make 8 pancakes that are each 10 inches in diameter. But she decides that those pancakes are way too big for her grandkids, and she decides she's going to make pancakes that are only 2 inches in diameter instead. How many small pancakes will Grandma's recipe make? So we kind of treat this probably like it's either an area problem or a perimeter problem. This one to me sounds like an area problem, right? So if I consider all the pancakes to be like the same thickness, then here's what I know. I can make, if I draw one of the big pancakes here, and that pancake is 10 inches in diameter, then I know the radius of that pancake is only 5 inches, right? So redraw it again. Maybe I'm interested in this. This is a 5-inch diameter pancake. Well, what's the area of each of those pancakes? We know the area of one of those pancakes is pi r squared, which is pi times 5 squared in this case. So I've got 5 squared is 25. Each pancake is 25 pi units, right? Square inches. Well, Grandma's recipe will make 8 of those. So if I multiply that number times 8, I had 25 pies. So think like dollars and cents, right? If I had a quarter, if I had 8 quarters, I'd have $2. Okay, you know what? 25 pi times 8 would give me 200 pi square inches. So here's what we know. Grandma's recipe, as is, will make 200 square inches of pancake. Now, that we can use big pancakes, or maybe we can do little pancakes, right? And so the question is this. Listen, if it's only 2 inches in diameter now, if the pancakes, if I shrink them down and it's 2 all the way across, well, really what that means is the radius is 1 inch. And I know that the area of that pancake is pi r squared, which in this case is pi times 1 squared, and 1 squared is just 1. They're literally just, hey, listen, it's pi squared inches each. Well, Grandma's recipe will make 200 pi square inches. Kind of looks like, you know what? I can make 200 small pancakes, can I? 200 times pi would give me 200 pi. Or what I can do is I can just take 200 pi, I can divide the big by the little, and I see that the pi's go away. I can make 200 small pancakes using Grandma's recipe. So there's a typical word problem. It's just relating areas of big shapes to little shapes and trying to find out how many of the little shape will fit inside of a big shape. All right? Okay, let's look at a different one. Problem number 2. You have a square piece of paper with an area of 400 square inches. You draw a circle on the paper so that the circle just touches each edge. What's the area of the circle? So here's what we're talking about, all right? If I drew, and I'll try to draw it as square as possible, okay? If I have a square, here's what I know. The square has all 4 congruent sides, right? And so I don't know what the base is. I'll call it x, but I know that the height has to be the same, right? And the area of a square is going to be base times height, which in this case is x squared. Base times height, which is x times x, which is x squared. And in this case, that x squared is equal to 400. So how do I get rid of a square? Well, I square root both sides, right? If I square root both sides, ignoring the plus or minus, because I'm not going to have a negative side dimension, that wouldn't make any sense, it looks like then x is 20. So this is a 20 by 20 piece of paper, right? Now we've figured out what the paper looks like. Let's talk about that circle. We're going to draw a circle on this piece of paper so that the edge of the circle does something like this. Ooh, oh my gosh, that is an ugly circle. Hey, you don't have to be a good artist to be decent at math. Thankfully, right? That is not... That should be a circle. Okay. The question is, what's the area of that circle? Well, you know, I don't really know. In order to find the area, I need to know the radius, right? So I can do pi r squared. So I'm curious then, if I drew a line from the center of the circle down to any of the edges, okay, I think it would be very convenient to draw it to a point where it touches the square. I want to know what that length is. Well, don't I know that the total length of the height of the square is 20, right? Isn't that 20 total from top to bottom? So then what's half of that? Gives me 10, right? Half of the square. So in my formula, I just replace r with 10. Pi times 10 squared, that'd be 100 times pi. It's 100 pi. Looks like square inches, right? Inches squared would be my units. Right, one more problem. Geez, that is a terrible circle. All right, one more problem. You have a piece of square paper. Oh, here we go again. This time they're telling us the perimeter of the square piece of paper. It's 32 centimeters. So I don't know much about my square, but I do know that whatever the base is, the height has to be the same dimension, right? That means I have to have x here and x here. They all four have to be the same. And this is what I know. Perimeter is found by adding up all the side lengths. So if I take x plus x plus x plus x, that's 4 x's for the perimeter. And those things have to add up to 32. Well, divide out the 4. X must be 8 centimeters, right? So it must be an 8 by 8 square piece of paper, right? 8, 8, 8, 8. There we go. There's my 32. Your dog Fido tore off 1/4 of the paper. What's the area? Notice it's not asking for perimeter anymore. What's the area of the remaining paper? Well, I think first we need to find out what was the area of the original paper, right? If I find the original area was 64 square inches. I get that by multiplying base of 8 times height of 8. 8 times 8 is 64. 1/4 of that is gone, right? Let's just say that Fido had a very square bite. And so this part disappears. Well, what's remaining? 64 divided by 4 gives us 16. I have 3 sections. If I divide it into fourths, it's like saying I have 3 sections that are 16 units squared each, right? Well, 16 times 3 would give me 48. I have 48 square centimeters remaining of the paper. You know, another approach before I end this video, and I go on to the next video with 2 more word problems, I could also say, listen, if 1/4 of the paper was torn off, that means 3/4 is remaining. So I could also say that I have 3/4 of that 64 square centimeters. I'm sorry, intercom of course has to come on in this. If I take 3/4 of 64, I would get the 48. There we go. So there's another way to look at it. I could say, instead of 1/4 taken off, 64 minus the 16, I could take 3/4 of 64 and get 48 the same way. Hey, it doesn't matter to me. All I care is that you're able to get the correct answer. So that's it for the first video. That wasn't too bad. We'll come back in a second with a second video, and that second video is going to be basically just a couple more word problems.